Very good morning to one and all present here. In today class, we'll discuss problems on normal distribution. So already we talked about normal distribution. So when we talk about normal distribution, it is a continuous distribution curve, which was first formulated by British mathematician D. Moore, and later on, lot of work on normal distribution was done by Gauss and Laplace. That's why the kind of contribution what the Gauss has given to the normal distribution, we call many times we call this as a Gaussian distribution also. So when we talk about a normal distribution curve, in the case of normal distribution curve, we believe it follow a bell-shaped curve like this. And in this bell-shaped curve, we believe that majority of your data will lie at the center, that we call as a measure of central tendency, where your mean, median, mode all will lie at the center. So that the property through which the possibility that your data will lie at the center, that we study in under measure of central tendency. Okay, so when we talk about under the measure of central tendency, this we reflect this as mu. Mu means your arithmetic mean or median or mode, geometric mean, harmonic mean, all the possibilities of your measure of central tendency. Now the it's like not all the data will lie at the center. Data will disperse from the center. So possibly it can be the scenario that your data can disperse plus minus of one standard deviation. Okay, so how much percentage of data can disperse in the plus minus of one standard deviation, and how much data will lie in that region? That is around 68.27% of your data will lie in the plus minus of one standard deviation. Similarly, when we look beyond, when we see beyond, then your data can lie in the plus minus of two standard deviation. So we have studied something called measure of dispersion. Under measure dispersion, we studied standard deviation, variance, range, quartile deviation, coefficient of variation. There we studied that not all the data will lie at the center. Data may be dispersed from the center, and that possibility that the data can disperse from the center, that we studied in measure of dispersion. So when we talk about measure of dispersion, so there we studied 95.45% of the data will lie in the plus minus of two standard deviation. So please understand this. Okay, so please understand that your 95.45% of your data will lies in the plus minus of two standard deviations. Similarly, there is a possibility that your data, there is a possibility that the maximum dispersion what your data can show, that can be in plus minus of three standard deviation. And when we discuss that, so we assume that 99.73% of our data will lie in the plus minus of three standard deviation. So this is what we studied in the normal distribution curve. So under the normal distribution curve, we have a measure of central tendency where our central part of data lies, and then our data can disperse from the center. So either in plus minus of one standard deviation or two standard deviation or three standard deviation. That is what the property of normal distribution curve is all about. And we studied the probability curve also. So the probability curve of x here is 1 by sigma root 2 pi to the power minus x minus mu whole square by 2 sigma square, where we know that your x lies between minus infinity to plus infinity, your mu lies between from minus infinity to your plus infinity. Okay, and the sigma standard deviation, that should be greater than 0. We have studied all this already in the past. Okay, so when we talk about standard normal distribution curve, guys, whenever we talk about standard normal distribution curve, in the case of standard normal distribution curve, your mean will be 0 and your sigma will be equal to 1. Please understand that for a standard normal distribution curve, for a standard normal distribution curve for a standard normal distribution curve. For a standard normal distribution curve, your mean will be equal to 0 and your sigma will be equal to 1. Okay, and under that case, the formula of a frequency distribution, that is here this would be 1 by root 2 pi e to the power minus x square by 2. Okay, so this would be your frequency distribution curve. Okay, so when we talk about this frequency distribution curve, so this or better way I should write the z value, because ultimately through normal distribution curve we are working on a z calculation. That is the usual symbol what we follow, minus z square by 2. So this value, this z value, we try to plot in the normal distribution curve. So what we do when we are solving the problem, here whatever the problems you get, which is a problem related to area under the curve, what you do, you assume that your z is 0 at the center, your z is 0 at the center, and then you will see the movement in the z. Then you'll see the movement. So then you'll see the movement along the values of z. So where, remember, at the center this value is 0, z value is 0. Remember, 50% of area will lie on the right hand side of z, and 50% of the area will lie on the left hand side of z. Okay, so imagine if I ask you any value. Imagine if I ask you any value, that suppose if I ask you find the area. If suppose if I ask you find the area under the find the area under the standard normal curve. Find the area under the standard normal curve. Find the area under the standard normal curve between z equal to 0 and z equal to 1.2. Find the area under standard normal distribution curve between z equal to 0 and z is equal to 1.2. So what you will do, you plot a normal distribution curve. Here the center your z is equal to 0, and all positive value will lies on the right hand side, and all negative value will lie on the left hand side. So this is z is equal to 0, and if I take z is equal to 1.2, 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 I need to find this area. So you simply write the area formula will be 1 by root 2 pi, 1 by root 2 pi e to the power minus z square by 2 dz. And the value, you have to take the value, uh, a definite integral value from 0 to 1.2. This value, if you take from 0 to 1.2, so for this value what you take, so the value what you get, you simply have to go to the table, normal distribution table. Okay, in that table, see 1.2. 1.2 correspond to what value? 0.3849. In the table, 1.2. 1.2 correspond to what value? 0.3849. That is your answer. The answer is 0.3849. Clear, everyone? Anyone, any doubt? Okay, suppose similarly, if I ask you, find the find the area under the normal curve Find the area under the standard normal curve. Find the area under the standard normal curve. Find the area under the standard normal curve between z is equal to minus 0.46 and and z is equal to 2.21. All this. So if you want this, this is z is equal to 0, and then you have z value minus 0.46, and then you have z value 2.21. Okay, so I need to find the area. Are you getting this? So z value between, you have to find the area of this. You have to find the area of this region. You have to find the area of this region. You have to find the area of this region. You have to find the area of this region. So how will you find the area of this region? So the area of this region, how will you find? This is the area A1, this is the area A2, guys. So to find the area of this region, how will I find the area of this region? You can understand. I have to find the area between z is equal to minus 0.46. Okay, so that lies on the left hand side. At the center, we assume the z2 is 0. So left hand side will be z value, negative z value, and 2.21. So that will lies on the positive side. So in between, I have to find the area. I hope you are understanding this. So now if I want to find the area, if I want to find the area, so this area A1, the area A1, formula of the area A1 would be the root of pi. That would be from 0, that would be 0 to 0.46, that would be 0 to 0.46, or that would be minus 0.46. Yeah. So that would be minus 0.46 to 0. Okay, that would be minus e to the power minus z square by 2. That would be that area, and then a2 area, a2 area will be 1 by root 2 pi. Then this will be from 0 to 2.21 e to the power minus z square by 2. So you get a1 area, you get a2 area. Okay, so the sum total of their area is your final area. So the area under the normal distribution curve from minus 0.46 to 2.21. So it is nothing but that is the sum of this area, A1 plus E2. So you can find the value. So 0 to minus 0.46. So you can simply open normal distribution curve 0.46. You can see this is right hand side, the area under right hand side, and the left hand side 0.46. So no, don't see this value correspond here. No, just ignore the sign here. You can just ignore the sign here. You can just ignore the sign here. So I want 0.46 value, right? I want what? 0.46, right? This value I want. Suppose if I want this value, suppose I want this value, ignore the sign. So 0.46, right? 0.46 means uh, when you see row wise see the zero point 0.4 value, and column wise see 0.06. So 0.4 and then 0.06. If you see, you'll get the value called 0.1772. Can you see this, guys? 0.1772. Can you see this value? So 2.2. Everyone understanding? Everyone understanding? Yes or no? Suppose I want 0.46 value. How will I see 0.46 value? Do you understand how to see the value? 0.46 value, guys. Are you understanding? How will you see 0.46 value? This is zero point 0.4, right? 0.46 value if I want to see 0.46 value, if I want to see 0.46 value, this is zero point 0.4 and this is 0.06. So 0.46 means this value. Are you understanding this? This would be 0.46. This value will be 0.46. Anyone, any doubt? Yeah, so this would be if you 0.46 means that is 0.177 plus. Then next value is 2.21. 2.21 means 2.21 means right. See here 2.2 and then 1 means 0.4864. 0.4864 plus 0.4864. You simply add them. If you add them, you'll get a value called 0.6636. This is the area. So this is the area corresponding to the normal distribution curve between z equal to minus 0.46 to z is equal to 2.21. Similarly, if I ask you to solve this question, can you solve this question 1? ABC. Tell me, guys, is this possible for you to solve question number 1, ABC, while looking into normal distribution curve? Imagine if I want the z value greater than or equal to 0.85. If I want z value, if I want z value greater than or equal to, if I want z value, this is z equal to 0, right? This is z equal to 0. What value I'm looking for? Z value greater than or equal to 0.85. Z value greater than or equal to 0.85 means this is 0.85 now. If you see this area, guys, this area is basically this area. What this area will give you, guys? Suppose this is A1. What A1 will give you, guys? A1 will tell you. A1 will tell you all the area from 0 to 0.85. A1 will tell you all the area from 0 to 0.85. Can you understand this? Guys, A1 will tell you all the area from 0 to 0.85. So all the area between 0 to 0.85, you can see in the normal distribution table, 0.85. 0.85 means 1, 2, 3, 4, 5, 6. 0.3023. 0.3023. This is 0.3023. Okay, everyone. But what area you want? You want all the area greater than or equal to this, greater than or equal to 0.85. You want all the area which is greater than or equal to 0.85. If you are looking actually the area, if you are looking, if the area what you are actually looking for is all the area which is greater than or equal to 0.85. Are you understanding? So the question was that you are looking for the area, you're looking for the area of Z which is greater than or equal to 0.85. So you know that the total area is zero point 0.5. You know this total area is zero point 0.5. Beyond right hand side zero point 0.5, left hand side it is zero point 0.5. You are talking about the area. If you're talking about the area which is corresponding to 1 by root pi. If you're talking about the area, if you're talking about the area which is corresponding to 1 by root 2 pi infinity to 0.85 minus z square by 2, that area is nothing but that is zero point 0.5 minus 0.3023. 0.3023. So the area corresponding to that is 7, 9 minus 2, 7. This is 9, 9 minus 3, 6. 0.6977. Oh, sorry, wrong answer. 0.5 minus 0.3023. This is 7. 9, 9 minus 2. 7, 9, 9. This is 1. 0.1977. Anyone, any doubt? Your final answer will be the area corresponding to that would be 0.1977. Clear? Anyone, any doubt? Anyone, any doubt, any question? Any question, anyone? Anyone, any question? So now if you see the second part of the question was probability minus 1.64 greater than equal to z greater than equal to minus 0.88. So if you see this question, here, you see this here your z is equal to 0. You know that your z is equal to 0. So here you'll get z1 is equal to minus 0.88, and here you'll get z2. Here you'll get z2 is equal to minus 1.64. Are you getting it? So you actually looking for this value, guys. We are looking for the z value which should be lesser than minus 0.188 and greater than minus 0.1644. You are actually looking for this area. You are actually looking for this area. Are you understanding? This is the area what you are actually looking for. Yes or no? You are actually looking for this area, guys. You're actually looking for this area. So how will you find this area, guys? So there is no direct formula, guys, to find this area. So if you are actually looking for this area, then you have to find this area by, if this is area A2 and this is area A1. So you can find this area probably. So the area what you are looking for from minus 1.64 to minus 0.88 minus z square by 2 1 by root 2 pi. This is the area what you are looking for. So this area you will get by subtracting the total area from minus 1.64 to 0. Okay, so this total A2 minus 1 by root 2 by 1 by root 2 by e to the power 1 by root 2 pi e to the power 1 by root 2 pi e to the power, then minus z square by 2 dz. You can write here dz, here dz. This that would be from minus 0.88 minus 0.88 to 0. Okay, guys. This is all at dz. Okay, here put dz. So if you do this, you'll get the area. So this is the required area. So this required area, what you are trying to get, that would be A2 minus A1. Clear, everyone? So this, so find the value from 0 to minus 1.64. Find the value 0 to minus 1.64. 1.64 would be 1, 2, 3, 4, 5, 0.4495. 0.4495, 0.4495 minus, then 0.88. 0.88 means 0.88 is 0.3106. 0.3106. 0.3106. 0.3106. That will give you this required area. This will give you your required area, e to the power minus z square by 2 dz, uh, 1.64 to minus 0.88 is 1 by root 2 pi. So this area what you are looking for is actually this. It's 0.4495, 0.4495, 0.3106989831, 0.3189. This is the required area. Clear, everyone? Anyone, any doubt? Any doubt, anyone? Anyone, any doubt? The third question, the third part of the first question, the P Z value less than or equal to minus 2.43. Less than or equal to minus 2.43. To plot a normal distribution curve where Z is equal to 0. Here your Z1 is equal to 2.43. So you want Z value, if you want Z value lesser than or equal to, you want Z value lesser than or equal to, so lesser than or equal to 2.43. So what value we are corresponding to that? So 2.43, 2.43, 2.4, 2.43. Okay, so you can see your how much you have closed. You know that now at two standard deviation you have 95%. Then three standard deviation you three standard deviation you have around 99% data. So here what I'm looking for lesser than this. Actually I'm looking for these values. I'm looking for this value lesser than 2.43. All the values which are less than 2.43. Greater than 2.43 will be the right hand side. All the values, this is area what I'm looking for. This is the area what I'm looking for. You know this, right? This area, this is 0.5. You know that this is 0.5. And this area you can find very easily. This area you can find very easily. How will you find this area? This area would be 1 by root 2 pi e to the power minus 2.4320 minus z square by 2 dz. So that you will get the answer very easily. What is that area? That area is 2.43 means 1, 2, 3, 4, 0.4927, 0.4927, 0.4927, that is 0.4927. So what is the area, required area lesser than? So the area what I'm looking for this area 1 by root 2 pi e to the power from minus infinity to minus 2.43. Okay, e to the power minus z square by 2 dz. This value is nothing but it is zero point 0.5 minus zero point 0.5 minus 0.4927. 0.4927. 3, 9 minus 2, 7. Then this would be 8. This would be 0.5, 0.4927, 3, 7. And this would be 0, 0, 0.007. Anyone, any doubt? Anyone, any doubt? Clear, everyone? You can try this kind of question, guys, by yourself. These are very basic questions. You can try by yourself. Imagine there's a question like this. Question number 2. If there's x is a normal, question number 2, if x is the normal variate with mean is equal to 12 and standard deviation is equal to 4, find x greater than equal to 20. So here this is normal distribution curve. If you talk about normal distribution curve, here your mu is equal to your mu is equal to 12, your mu is equal to 12, your sigma is equal to 4, and you're talking about 20, right? You're talking x bar value equal to 20. Okay. So x bar value equal to 20, guys. So this area you can find very easily by using normal distribution curve. So by using normal distribution curve, you can easily find this area. By using normal distribution curve, you can easily find this area. what is the area? So suppose if this area is A1, what is the area under this? The area under the curve. What is the area under the curve? Z1 suppose. So that would be the formula what you have to use is x bar minus mu by sigma. So this is the formula what you need to use. So 20 minus 12 by 4. So this is equal to 2. So see the value of z equivalent to 2 here in the normal distribution curve. The value of z equal to 2 is 0.4772. The value of z is 0.4772. So this is the area. This is the area. This is the area from 12 to 20. If I'm looking for the area, if I'm looking for the area which is greater than or equal to 20, then my required area will be zero point 0.5 minus 0.4772. So my answer would be 8, 9 minus 7, 2, 9 minus 7, 2, then 0, 0.0228. That would be my area. Anyone, any doubt? This would be my area. They're expecting us to find this area. They're expecting us to find this area. This is the area greater than or equal to 20. They're expecting us to find this area greater than or equal to 20. Are you getting it, guys? They're expecting us to find this area greater than or equal to 20. Is this clear, everyone? Are you getting this area? Now, if I ask you, if I ask you the other end of the question, if I ask you find the probability of x less than or equal to 20. So greater than or equal to 20 already you got right. And the total area you know is 1. So if I want remaining area, this already I got, this area is 0. This area already I know this area is 0.0228. If I know this area is 0.0228, if this area is 0.0228, I want all the remaining area. I want all the remaining area. I want all the remaining area. You know that total area is equal to 1. 50% left hand side, 50% right hand side. So if I want remaining, then remaining, you are getting it right. So 0.0228. If you want all the value of x less than or equal to 20, that is nothing but 1 minus 0.0228. So this is 297,979. So that would be 0.977. Are you getting it, guys? Are you getting it, guys? So if you have to find, see, when you had to find the area here, when you had to find the area, if greater than equal to 20, so always by using this formula, this is the formula. So by using this formula called x bar minus mu by sigma, by using this formula, you can find the area from your central to any particular region. You can find the area from your central axis to any particular. So I found the area by using this formula and then locating the same value in normal distribution. I got the area between 12 to 20. That area I got. Now if I look area, if I'm looking for an area greater than 20, then that would be 0.5 minus this area. And then looking for all the area less than 20, then it would be this. Clear, everyone? Any doubt? So the total area of this curve is 1. 50% of the area lie on the left hand side, 50% of area will lie on the right hand side. Clear, everyone? So this much I'll do in today's class. We'll continue discussion tomorrow. Any doubt, anyone? So I'm ending the class. Anyone, any doubt? So this class I'm ending. I'll see you all tomorrow. Take care. Bye everyone.